Thank you for that. So this is only a short talk. I'm happy to take questions afterwards, either explicitly about robots on Mars or more generally about university life, if you would prefer to ask questions on that topic. So yes, this is part of a series on exploring the solar system, and this happens to be part one, looking at robots on Mars. So I'll be having a quick look at Mars and Martians, looking at landers and rovers, asking what have they found, and asking what comes next. I will be recording this talk, and there are handouts being circulated. I'm happy to provide the PDFs of these handouts, and also a recording of the talk I'll be sending on to Paul to distribute if anybody couldn't make it to this particular group here. So there was long-standing interest in Mars. We Earthlings have had an interest in Mars for an awful long time. You can date that back to the first idea of whether or not there are such things as Martians. You can take that back to the War of the Worlds. Whether it be the original book from H.G. Wells, whether it be the radio program, whether it be the movie, or whether it be the musical. But of course, these days, if you talk to youngsters about what you mean by the Martian, they don't think of necessarily the War of the Worlds. They think of what Matt Damon has been getting up to on the Martian planet. But we should just take a second to remind ourselves how amazing it is that we're able to do this. 100,000 years ago, some of us were still living in caves. And yet now, it is possible for people to design and build a rover that can go on the top of a rocket, get sent to Mars, land on Mars, and then send back images like this. A genuine panorama taken by the Perseverance rover just a few years ago. We don't think there's any life on the surface there, but we have reason to believe that water has definitely flowed on Mars. If water has flowed on Mars, it might still be there under the surface. It's difficult to tell whether there's life there. Maybe there's life under the surface in subsurface water. Maybe even if there's not life there now, maybe there was life some time ago. And one of the reasons for visiting Mars and exploring it is to try and answer the question if we are alone or whether there's life elsewhere. And it's easier to look for life on our doorstep than it is to look for life elsewhere in the galaxy. So I haven't got time to talk about all the ways robots have been used on Mars. If we have a look at a few of the landers and rovers, by all means, come in. If we have a look at landers and rovers that have been on the surface, here I'm just looking at the set from NASA. There have been other landers. Remember, China have also landed on Mars as well. But if we look at NASA, from the 1970s, from the mid-1970s, there was the Viking landers. And then we've had a number of different rovers throughout the noughties into the teenies. We've had Spirit and Opportunity, small rovers. And then we've had Curiosity and then later Perseverance. Perseverance, otherwise known as Percy to his friends, and occasionally Opportunity is known as Oppie. So there are a number of different landers and rovers, which I haven't got time to explore in detail. So I'm just going to have a few words about those landers and rovers that are there highlighted in red. And to me, the Mars story starts in 1976, because at that time I was roughly your age, give or take a little bit. So in the mid-70s, I remember this happening. No, we didn't send Carl Sagan to Mars, but here he is standing next to a model of the Viking lander, just to provide an idea of scale. You can see it's still a relatively large object. It didn't have to move anywhere, so it was about the size of a car, and that was landed on Mars back in the mid-70s, 1976, and it sent back the first colour images of the surface of Mars. And I thought that was absolutely amazing. In the mid-70s, I was a teenager, and I thought, yes, men have walked on the moon, but it's also possible to send spacecraft, to send robots to other planets, and to come back with colour images. And that colour image really sparked my interest, realizing that, well, there is definitely the possibility of us visiting other worlds and seeing what they look like. In this particular case, there's a little trench at the bottom because Viking took a soil sample to try and get an idea of whether or not there were any microbes in the surface there. But if you ask yourself, well, how do we get a lander like that? A small lander might only be a few hundred kilograms. A large lander or rover might weigh a ton or so. How do we actually get those to Mars? Mars is clearly tens of millions of miles away, so do we need an absolutely huge rocket to get there? Well, actually, the rocket you need to get to Mars is considerably smaller than, for instance, the Saturn V that put men on the moon back in the 60s. Going to Mars, tens of millions of miles, a much longer journey than going to the moon, which is right on our doorstep at only 250,000 miles away, 400,000 kilometers. So why is it that going a very short distance needs an absolutely huge rocket like a Saturn V, whereas going to Mars, much further away, only needs a relatively small rocket? It's basically nothing to do with the distance. That's not how orbital mechanics works. If you want to go from Earth to Mars, all you need is a little bit of a nudge in the right direction, and that will get your object to Mars. What matters is how much mass are you trying to shift. In the case of going to Mars with a rover, you might only be lifting a few hundred kilograms or maybe a ton into Earth orbit and then sending it on its way to Mars. But for the Apollo moon landings, the Saturn V rocket had to lift over 100 tons into Earth orbit, which then took the astronauts to the moon, landed, came home, etc. So it's the difference, not in the distance, it's the difference in the amount of mass you have to lift that dictates the fact that you need huge rockets to get to the moon, but only small rockets to get to Mars. Let's have a look at how Spirit and Opportunity, the first rovers, the first NASA rovers, did that. Here's Spirit and Opportunity. It doesn't matter which one. Let's assume this is Opportunity. The first thing it does is aerobrake. It hits the Martian atmosphere, very thin, but at high speed, and so it uses an aerobraking maneuver to slow down. And then it deploys a parachute. At this point, it is still supersonic. Testing a supersonic parachute on Earth is difficult, but now the heat shield can be removed, and that reveals a little package, a little pyramid there, and the rover is sealed inside that pyramid. So the question is, if it weighs a few hundred kilograms, how do you get it safely to the surface? Well, the solution? Airbags. Rather than deal with a precision landing, which is difficult to do, you slow down to a reasonable speed and then you just let it go. And you let it bounce. And you let it bounce. And you let it bounce. As long as your rover is tightly packaged inside this bouncing ball, then hopefully it will survive. It's packaged in such a way that it can take huge G-forces, and those G-forces would be measured by the accelerometers inside, just like you've got accelerometers in your phone. In the case of Opportunity, it bounced 28 times before it finally came to rest, and they could deflate the airbags. Hopefully what's inside is a pristine rover, if it all worked correctly. So it unwraps itself and rights itself, and then the rover, which is hopefully still in one piece, is inside and starts to unfold itself. One of the first things the rover has to do is to unfold the solar panels. What is key to virtually all exploration of all planets is having enough power to power all of the systems you need. So the first thing that happens is the solar panels unfold, like a rather dainty butterfly here. Once the solar panels are out, a mast rotates to bring a stereo camera up to the point where it can have a look at the terrain around it. And this thing in the background that looks like a table tennis bat, that's a little phased array antenna which allows the rover to talk to a ship in orbit and ultimately back to Earth. So having landed, it takes a look around, reports back to mission control on Earth, I seem to have landed safely. Remember, it takes maybe 15 minutes or so for the signal to go from Mars back to Earth. So the system sits there for a while until mission control says, yes, we've checked out all your systems, everything seems to be fine, you can now go and start roving. So it's then given the signal to actually unpack its wheels, because its wheels are folded up underneath to make it easier to sit inside that tetrahedron. It unfolds its wheels, there they go, and then it does a final check as to where it is. The stereo camera on the top looks around and works out where the rocks are and where it's going to go to see if it can navigate safely off its landing pad. So basically, it then starts its journey. Spirit and Opportunity rovers, which are about the size of a coffee table or so, they were designed to last about 3 months and were designed to roam over the Martian surface for something like 3 months. But NASA is very conservative when it builds these things. Although Spirit didn't last that long, Opportunity, which lasted significantly longer, lasted considerably longer than 3 months. It lasted 14 years on the surface. And the limit to how long these systems last is dictated by these solar panels. Here's a selfie taken from the camera looking straight down onto the solar panels. Here, the solar panels are relatively clean. You can see the rather red Martian soil in the background. But because the Martian atmosphere is rather laden with dust, it doesn't take too long before the solar panels might get covered. And sometimes that limits the lifetime of any devices, whether they be landers or whether they be rovers on the surface of Mars. And once you get the solar panels covered with Martian dust, for instance, as in this case, you can see that you can hardly tell the difference between the solar panels and the background Martian dust, because there's so much dust on the solar panels. Clearly, the efficiency of these systems has been greatly reduced. You might say, why don't they do something about that? Why don't they put, I don't know, windscreen wipers or have a dustpan and brush to actually brush the soil away? Well, this stuff is a bit like volcanic ash. It is very sharp. So if you try to brush the Martian soil off the solar panels, you would end up scratching the solar panels, and then you would lose efficiency anyway. So basically, Mars and other landers put up with the fact that sooner or later, your solar panels are going to get covered. It might happen in a few months. You might be lucky and have a dust devil come along and blow some of the dust off the solar panel and extend your life perhaps a little bit longer, which is what happened with Opportunity. But when we think about the conditions on Mars, the tilt of Mars is very similar to the tilt of the Earth, 20-something degrees, 23.5 in the case of the Earth, about 25 in the case of Mars. And the length of time they take to rotate is very similar as well. 1 day, of course, for the Earth, and about 24.5 hours for Mars. So the day-night cycle of Mars and the seasonal cycles of Mars are very similar to those on Earth, Martian year being a little bit longer than an Earth year. But on Earth, our day-night temperatures are mitigated by the fact that we've got an atmosphere which keeps the planet warm at night. Even when the sun isn't shining on the Earth, the atmosphere keeps us warm. But Mars has got a very thin atmosphere, which means there's a huge difference between the day and the night temperatures. The rovers have to keep warm, which means they need power from their solar panels to charge their batteries, to operate their heaters to keep them warm. Because the day temperatures might be rather pleasant, like it could be above freezing, possibly even as high as 20 Celsius or so, but the night temperatures can absolutely plummet, down to -100 or lower in the case of a Martian winter. The thin atmosphere means you get huge temperature differentials. And you need those solar panels to charge your batteries to keep you warm during the night. Otherwise, you freeze, and generally speaking, electronics don't like to be very cold, and so if the entire system freezes down to the point of -100 or so, it will be almost impossible to reboot the next day. And this is what ultimately limited the lifetime of Opportunity. It wasn't because it crashed into anything, it wasn't because it lost a wheel, it was because ultimately it found that it was entering a Martian winter night, and there was a dust storm during the day. A dust storm meant that there was loads of dust in the atmosphere, which means the solar panels could not recharge the batteries, and the batteries were failing. And so the last transmission that was obtained from Opportunity, 2018, some 14 years after it landed, so it had an enormous lifetime, much longer than the planned 3 months or so. But the last transmission from Opportunity, it knew it was in a dust storm, it knew it couldn't see the sun during the day, and it knew it couldn't recharge its solar panels. So the last transmission from Opportunity was battery low, getting dark. And that's the last we ever heard of Opportunity. It simply did not survive that night. So what are you going to do about the fact that rovers have this limitation of you need solar power in order to charge your batteries in order to keep you warm? NASA decided that for the next couple of missions that they wanted to fly to Mars, they would not have solar panels to keep them warm. They would use a different system, so-called thermoelectric generators. And these thermoelectric generators are basically some plutonium-238, which gets hot because it's an alpha particle emitter, and then you have a whole lot of thermocouples around it, which provides you with electrical power. And basically, you get that power for free in the sense that it's got nothing to do with solar power. So Perseverance, Curiosity, and then later Perseverance, I'm going to talk about Perseverance, had a somewhat different mission profile because they didn't have solar panels. They were expected to last much longer with their thermoelectric generators. But Curiosity and Perseverance are much larger rovers. They're not simply the size of a coffee table, they're the size of a car. They weigh a ton or more. So the problem is, how do you get those down onto the surface? So again, we can look at a little animation that gives us an idea of how Perseverance got to Mars. The start looks very similar to Opportunity. It's in an aeroshell, and it hits the atmosphere and it uses aerodynamic braking to slow down. There's Perseverance inside its shell, getting rattled around. The shell has some jets, and so the jets allow it to be steered to some extent. Again, a supersonic parachute to try and get it to slow down. But this weighs far too much to use airbags. So what are you going to do? You drop it from a height, and then you fire retros. You can't take those retros all the way down to the surface because they would kick up so much dust, they would clog the rover's operation. So they want to work out where they are. Cameras look down so that the rover figures out where it is and where it wants to land. And without getting too low, they then say, right, go into a hover once you've decided where it is you want to land, and then you winch the rover down on cables until it hits the surface. Then you cut the cables, and the sky crane goes flying off and crashes somewhere out of harm's way, leaving Perseverance, and on the right there is its thermoelectric generator. Again, you notice no solar panels anywhere. So there's Perseverance sitting on the surface, waiting to start its roving. And this particular long, slow pullback in this animation is a reminder that even if you've got half a dozen or so rovers on the surface of Mars, and even taking into account that Mars is a little smaller than the Earth, there's still a fairly big planet to explore. And these rovers don't travel very far, they don't travel very fast, they go very slowly, very carefully, so they might travel many, many kilometers, but they don't travel thousands of kilometers during their life. And so we have still only explored a very small fraction of the surface of Mars using these rovers. So there's Perseverance sitting on the surface. This is a selfie. There's Perseverance, otherwise known as Percy. And there on the side there is a little helicopter called Ingenuity, or Ginny to his friends. And so in this particular case, you can see Percy is sort of just looking at the selfie camera and then looking down at the helicopter like a nervous adult, a nervous father, trying to make sure the toddler hasn't run away and done anything silly. How do you end up with a selfie like that? Well, we all know how to take selfies. We get a phone, we hold it up, we go click, and we've got a selfie. With a system like this, it is still possible to obtain a selfie because not only have you got cameras in the main mast itself, there's a camera on the arm that is used to go exploring and drilling into rocks to test them. And that camera can be used to take a whole series of individual images, not just one snap, but it takes a whole series by moving the camera in a particular choreography. And this is the way it's done. The camera on the end of the robot arm is moved so that the lens stays in the same place whilst the camera moves backwards and forwards to get the entire montage, which then is stitched together to make the entire image. In this case, it's taking two images with the masthead there in two different orientations. So that's how these selfies are obtained, and the actual arm holding the camera is essentially taken out, so it looks like it's taken from a floating camera, but it is taken from Perseverance itself. Where did the helicopter come from? Well, the helicopter came in on the underbelly of Perseverance. It was underneath a plate as it came down and landed, and once it was landed, the plate fell away, and there's the Ingenuity helicopter underneath Perseverance, and it was basically dropped. And once it was dropped onto the surface, Perseverance trundled away and allowed the helicopter to do its thing. So here's a view from Perseverance. There's Ingenuity, the helicopter itself, down in the bottom left-hand corner. And then basically Perseverance took a number of different videos of the Ingenuity helicopter flying. Perhaps you can hear there a little bit of wind noise, but perhaps you can also hear a hum. That hum is the sound of the helicopter blades turning. So you're listening to a spacecraft on another planet. This helicopter was sent and did a number of test flights. It wasn't designed to do anything in particular other than prove that it is possible to fly on another planet. This is the first time any spacecraft has flown on any other planet. You can't do this on the moon, of course, because you've got no atmosphere for the helicopter blades to push against, but you can do that on Mars, even though it's a very thin atmosphere. As long as your blades are large enough and as long as they turn fast enough, you can get enough purchase to actually hover or fly. And the idea is that for rovers, this could be really useful because rovers don't travel very far and you always want to avoid the rocks, and ideally you want to be able to look over the horizon to know what's over the next ridge, what's over the next hill. So with a helicopter, you can fly it further and report back, don't go this way, go that way. It'll be a much easier track for you to follow in order to get from A to B. So helicopters might be very useful for helping other rovers in the future. But also, it was a technology test to see whether or not it's possible to fly helicopters in other environments. And there are already plans to send a helicopter to one of the moons of Saturn. Titan has a very thick atmosphere, and therefore, in principle, you can design yourself a helicopter or a quadcopter, which is much heavier, which means you can have much more scientific equipment on board in order to explore this particular moon of Saturn. So there are already plans, the so-called Dragonfly mission, to send helicopters to other worlds. NASA are always keen to get people on board. They're always keen to publicize the missions they have for exploring Mars or exploring other parts of the solar system, which is why it's been possible for a while now to get yourself boarding passes. If you're really interested, you can actually get a boarding pass. I applied for one for the Mars 2020 mission. In other words, what ultimately became known as the Perseverance rover in 2021. Basically, you can get yourself a boarding pass, and that boarding pass is then placed inside one of the chips in a plate on the rib, and that rib is sitting on the back of Perseverance. So my boarding pass with my name on it is sitting on Perseverance. So when Perseverance roams the lunar landscape, I'm going with it, or at least I can feel certainly engaged. Yes, I'm a taxpayer, so I've partly paid for a lot of this technology. But the idea that your name is actually going to Mars, or your name is going to the outer solar system, or one day your name might be flying around on one of Saturn's moons, it doesn't cost you anything, and it doesn't cost NASA anything, because what are they doing? They're putting your name on a small chip. It adds a milligram to the total weight of this 1-ton rover, so it really makes no difference to NASA, but it gets people on board, it gets people motivated, it gets people engaged with the whole idea of being involved with space exploration. And you could argue, well, why do we bother? Why do we want to explore the planet Mars, for instance? We want to understand its geology and we want to understand its climate. It looks like it used to have a climate not so different from the Earth. It looks like there used to be water running in rivers. It looks like there used to be lakes there. There aren't any more, so we can ask ourselves, why did it change? Hopefully, understanding climate of other planets will help us get a better deal on understanding the climate of our own planet and what we need to do to make sure we don't ruin it. We're always addressing the question, is there life out there? That's one of the reasons we're interested in the moons of Jupiter and the moons of Saturn. We think there are oceans out there that could be supporting life. We think there's water on Mars that could have supported life. Conceivably still does, but even if it doesn't now, it did in the past. So we want to understand, does life exist, or did it ever exist on other planets or other moons, to get, again, a better idea of whether life here on Earth is unique or not. And some would argue that we're exploring Mars with robots because ultimately it'd be nice to visit with people, with humans. Now, that is going to be an enormous undertaking. It is not going to be cheap. It's going to be technically extremely challenging to send a human to Mars with the intention of bringing that human back alive. It is going to be so much more expensive than sending astronauts like the Apollo astronauts to the moon and back. The moon is only 3 days away. Mars is basically many, many months away, and you have to stay for a few months, and then it's going to be many, many months to come back again. So a Mars mission is going to be more like not 2 weeks. A Mars mission is going to be more like 2 years. And keeping astronauts alive for that length of time in a very hostile environment with a lot of radiation from the sun, from the cosmos, that is going to be very technically challenging. But some people say we need to explore other worlds in preparation for human exploration. One of the things that Perseverance is doing is collecting samples as it goes. Some of those samples are being dropped in its wake. Some of those samples are being kept on board. So it's collecting samples of rocks, it's drilling into rocks and taking samples. It's doing some chemistry to try and understand what's going on. It has a little sort of chemical laboratory on board to do some analysis. It has some spectrometry, etc. So it's trying to understand those rocks, but it could be so much better if we can bring those rocks back to Earth, rocks and atmosphere samples, because we have so much more sophisticated equipment in laboratories here on Earth than we can possibly put even into a rather sophisticated rover like Perseverance. So the intention is to take as many samples as possible, analyze what you can on the fly, but where possible, seal up some samples and ultimately prepare for them to be brought back to Earth. And that, of course, is again rather tricky. Sending a rover there, we can do that. How do you get those samples back again if those samples are currently being taken? Well, there are plans. Whether those plans will be seen through depends on funding bodies and how much money NASA has, and also the European Space Agency, ESA. But one idea is, as long as those samples are there, it is possible to bring them home. And one idea is you leave Perseverance on the surface and you have it joined by another lander, not another rover, but another lander that comes down. Perseverance then goes to meet it, and Perseverance takes all its samples with it, and one by one, Perseverance takes the samples it's been collecting and transfers them into this lander that has just arrived. And you can see here, it might have a few dozen of these samples. You then seal up the lander, but then what do you do? How do you get them back to Earth? The idea is these are actually loaded into a small rocket. And that rocket is then fired, and then Perseverance watches the rocket go back into orbit, and the sample chamber at the top end of this will then detach, meet up with a Mars orbiter, and ultimately then get transferred back to Earth. And if all of that can be done, keeping all of the samples sealed, then we can start analysing those rocks and those gas samples using systems back on Earth. This is a joint venture between NASA and ESA, the European Space Agency. This is the plan, but it is rather expensive, and it depends on funding in the next few years whether or not the sample return to Earth will look like this, or whether people will come up with a slightly different way of getting those samples home. It's going to be difficult, it's going to be expensive, but we've got those samples sitting waiting for us. Hopefully it won't be too many years before they come back to Earth, and then we can have a really close analytic look at those samples. So America haven't got it all their own way. Yes, there has been a Chinese rover on Mars as well, but it won't be long, perhaps 2028 or so, before this becomes a reality. This is an ESA rover. The European Space Agency is designing this. It's the Rosalind Franklin rover, and it's being built in the UK. This is us building a rover to go to Mars. The idea is, you can see it looks very similar to some of the other systems we've seen. It looks relatively small, it's got solar panels, it's not going to last that long. The difference with this rover is this black box on the front. This black box is a drill, and we'll be able to drill down quite a few meters below the surface. We know there's water down there. We think there might be life down there. If we can drill down a few meters, we might be able to find that. We might be able to see signs of microbial life on another planet. So that's what's being done by the UK as part of the European Space Agency. It is currently being built. Airbus UK are already building this thing. So here's a whole load of technicians at Airbus UK putting the Rosalind Franklin rover together. Somebody needs to point out to them that the back wheel appears to be missing. There seems to be only 5, and they've replaced it with a shopping bag. But hopefully they realise this and they will eventually get it right. So it's not ready to launch just yet, and it'll be probably a few more years. But you can see all the people at Airbus think this is fantastic. It won't be long before this is a reality. And hopefully it won't be long, only a few more years, before you can see the UK presence on another planet. There will be a Union Jack on Mars before too long. So I hope I've piqued your interest in how we go about sending robots to other planets, Mars in particular. If you're interested to find out more, you can go to the National Space Agencies, NASA, ESA.int, or the Chinese one who've landed the rover Zhurong back in 2021. Each of these sites will have lots of information about the technicalities and the reasons for wanting to explore Mars and other planets in our solar system. Thank you very much for listening.